Welcome to a stage in which marketing has surpassed engineering in the world of pickup trucks. Today, choosing a pickup solely for its aggressive design or its screens is, in many cases, taking on a long-term financial risk. Repair shops are receiving more and more vehicles with complex technologies that promise efficiency and power, but once out of warranty, translate into costly repairs and recurring failures. We spoke with mechanics who work daily with these models, technicians who open the hood and find more fragile electronics where there used to be simple and durable solutions. This is not a ranking to entertain. It is a practical guide to avoid expensive mistakes. Below, the 13 pickup trucks that specialists recommend not buying. 13. Ford Ranger Raptor, the off-road promise with the reality of costly maintenance. The Ford Ranger Raptor is presented as a mid-size pickup oriented toward off-road use, with a robust aesthetic and a long-travel suspension setup developed to absorb impacts on demanding terrain. In occasional recreational use, the vehicle delivers on its promise and offers a driving experience far superior to that of a conventional Ranger. The main critical point lies in maintenance costs when it is used intensively off-pavement. The high-performance shock absorbers designed to withstand repeated impacts show premature fatigue with frequent use in dusty or sandy environments. Over time, they can lose internal pressure and begin to leak oil, which reduces the suspension's absorption capacity. Since all four components degrade at similar rates, replacement is usually done as a set and represents a significant expense. The 10-speed automatic transmission, optimized for highway efficiency, faces greater demands in technical off-road driving. Constant operation at low speeds and high loads increases fluid temperature and accelerates its degradation. This can result in harsher shifts, delayed response, or activation of protection modes. To mitigate these effects, some workshops recommend shorter service intervals and, in certain cases, improvements to transmission cooling. The Ranger Raptor offers outstanding capabilities for recreational use, but it is not designed for intensive and continuous use in extreme conditions without assuming high maintenance costs. In the used market, units with a history of demanding off-road use tend to depreciate faster than those used primarily in urban settings, reflecting the risk of future expenses. 12. Chevrolet Silverado 2.7 Turbo, when fewer cylinders mean more problems. General Motors introduced the 2.7-liter turbo engine in the Silverado 1500 as an alternative to improve efficiency and comply with emissions regulations. This four-cylinder engine incorporates modern technologies such as direct injection and variable valve timing, and in light use it offers adequate performance with lower consumption than larger displacement engines. The problem appears when the vehicle is regularly used with heavy loads or for towing. To move a full-size pickup under these conditions, the turbocharger must operate constantly at high speeds and temperatures. This operating regime increases the thermal and mechanical stress on the forced induction system. In units subjected to demanding use, repair shops report premature wear in the turbo assembly. One of the first signs is a progressive increase in oil consumption, associated with degradation of the turbocharger seals. The oil that enters the intake system burns in the combustion chamber and promotes the formation of carbon deposits on valves and pistons, which over time affects performance and can cause irregular detonation. Other common symptoms include metallic noises during cold starts and a gradual loss of power. As the system loses efficiency, the driver tends to apply more throttle, which increases real-world fuel consumption and reduces the expected efficiency benefit. Replacing the turbocharger and addressing possible repairs associated with internal engine wear involve high costs, which in some cases exceed the fuel savings obtained over several years of use. This unfavorable cost-benefit ratio is reflected in the second-hand market, where Silverado models with the 2.7 turbo engine depreciate faster compared to versions with larger displacement engines and simpler architecture. This case illustrates the limits of downsizing applied to work pickups. Smaller, turbocharged engines can be efficient under light conditions, but under sustained demand they increase the risk of costly maintenance in the medium and long term. 11. Toyota Tundra iForce Max Hybrid, the break with the tradition of simplicity. Toyota has been recognized for prioritizing durability and mechanical simplicity in its pickups. The Tundra iForce Max Hybrid represents a significant shift by incorporating a full hybrid system to improve efficiency and comply with emissions requirements. The system combines a twin-turbo V6 engine with an electric motor integrated into the transmission and a battery located under the rear seat. Power and torque delivery are immediate, improving performance when towing or accelerating with a load, and fuel consumption is lower than in traditional V8 versions. The main challenge is the system's complexity and thermal management. The twin-turbo engine, electric motor, inverter, and battery concentrate heat generation in a reduced space, requiring the use of multiple cooling circuits with sensors, pumps, and valves. Under demanding use and in hot climates, premature degradation of the hybrid system wiring harnesses has been observed, with intermittent faults that are difficult to diagnose. Issues have also been reported in the hybrid system control module, which can activate protection modes or reduce electric assistance. Although software updates can improve management, hardware problems require component replacement with high costs outside of warranty. The battery may degrade faster in extreme temperatures, reducing efficiency over time. This is reflected in the used market, where the hybrid Tundra depreciates more than versions with simpler mechanical setups. 10. Ram 1500 TRX, the 700 horsepower Colossus with a proportional appetite. The Ram 1500 TRX is a high-performance pickup equipped with a supercharged V8 engine of great power, capable of delivering sports car-like acceleration despite its considerable weight. In addition to its straight-line performance, it incorporates a long-travel suspension, large all-terrain tires, and specific driving modes that allow demanding off-road use. The challenge is not its capability, but the operating costs associated with this level of performance. The supercharger operates at high revolutions and depends directly on engine lubrication. Any neglect in oil change intervals or lubricant quality accelerates wear of internal bearings, which can lead to costly failures of the forced induction system. A malfunction in this assembly implies high-value repairs and, in severe cases, secondary engine damage. Fuel consumption is high under normal conditions and increases significantly with aggressive driving. Added to this are the costs of high-performance spec brakes and tires. Brake pads and rotors require more frequent replacement than in a conventional pickup, and the large diameter tires carry a high unit cost and limited lifespan under intensive use. These factors make the total cost of ownership considerably higher than that of a standard Ram 1500. In the used market, many units depreciate quickly as potential buyers internalize maintenance and operating expenses. The TRX may be an appropriate option for enthusiasts with the financial capacity to sustain these costs, but for daily use or normal budgets, the associated expense level makes it a high financial risk option in the medium and long term. 9. Nissan Frontier. The inadequate transmission for heavy-duty work. It has been a popular option in the mid-size pickup segment due to its competitive price and adequate capabilities for moderate work. However, in some markets and production years, transmissions intended for lighter vehicles were adopted, which generated durability issues when applied to frequent load use. The CVT transmission operates through variable diameter pulleys connected by a metal belt or chain, allowing the ratio to vary continuously. In light vehicles and urban use, this technology offers advantages in smoothness and fuel consumption. The problem arises when it is used in a pickup that carries heavy loads or tows regularly. Under these conditions, the pressure between the belt and pulleys increases significantly, generating heat and accelerated wear. The specific CVT fluid fulfills critical functions of lubrication, cooling, and friction control. With sustained loads, fluid temperature rises, its additives degrade, and deposits form that affect valves and sensors. The first symptoms are usually vibrations during acceleration, delayed response, and noises under load. Over time, evident slipping or the system entering protection mode may appear, limiting power. Internal wear of the belt and pulleys is progressive and irreversible. Unlike conventional automatic transmissions, which can be partially rebuilt, a damaged CVT usually requires replacement of the entire assembly. The cost of replacement, including labor, is high and in vehicles with several years of use can approach the market value of the vehicle itself. This risk is reflected in the second-hand market, where Frontier models equipped with CVT show lower demand and greater depreciation. In contrast, versions with manual or conventional automatic transmissions tend to retain their value better and offer durability more in line with the typical use of a work pickup. 8. Volkswagen Amarok 5.6, German engineering with German complexity. The Volkswagen Amarok 5.6 TD1 is presented as a mid-size pickup with a premium focus, featuring a 3.0-litre turbo diesel engine that delivers high power and a driving experience closer to that of an SUV than a traditional work truck. The engine uses high-pressure common rail injection and precision injectors, which improves performance and smooth operation, but also makes it more sensitive to fuel quality. In markets with lower purity diesel, the formation of deposits in the injectors is common, leading to rough idling, loss of power, and intermittent faults that require specialized cleaning or component replacement. The EGR system, designed to reduce emissions, is also vulnerable to residue buildup when fuel quality is not optimal. Obstruction of valves and passages generates warning alerts and reduced performance, with repairs that involve disassembly and significant costs. Added to this are the availability and price of spare parts, which in many markets are higher and come with extended delivery times. Electronic diagnostics require specific tools, limiting qualified workshops and increasing service rates. The Amarok 5.6 is suitable for those who prioritize comfort and performance with high-quality fuel. For continuous work use with predictable maintenance, its complexity represents a greater risk compared to simpler alternatives. 7. GMC Sierra Denali, when luxury compromises durability. It is positioned as the premium version within the full-size pickup segment, with a level of comfort and equipment comparable to that of luxury SUVs. It incorporates high-end materials, multiple screens, and a wide range of driver assistance systems. One of its distinctive elements is the adaptive air suspension, which allows the vehicle height to vary and adjusts stiffness according to the driving mode. In predominantly urban use and with careful maintenance, this system can operate properly for long periods. The problem arises when the vehicle is regularly exposed to dirt roads, dust, or work use. The air bellows, made of elastomeric materials, are more sensitive to wear than metal springs. The accumulation of abrasive particles and exposure to contaminants accelerate the appearance of microcracks, which over time lead to air leaks. When a leak occurs, the compressor attempts to compensate continuously until it becomes overloaded, which can cause additional failures. Replacing a single air spring is costly, and replacing multiple system components can involve very significant expenses. For this reason, some owners opt for conversions to conventional suspension at lower cost, but losing height adjustment functions and affecting resale value. In addition to the suspension, the Sierra Denali integrates numerous sensors and electronic modules for cameras, assistance systems, and stability control. The high level of interconnection between systems means that the failure of one sensor can generate chain deactivations and multiple warnings on the dashboard. Diagnosing these issues often requires workshop time and specialized equipment. The Sierra Denali performs adequately as a vehicle for predominantly urban or recreational use where comfort is prioritized. However, when used regularly as a work tool under demanding conditions, several of its luxury systems become points of vulnerability that significantly increase long-term maintenance costs. 6. Isuzu D-Max Bi-Turbo, the complexity of the twin-turbo. The Isuzu D-Max has been characterized by its focus on robustness and reliability in markets with demanding use. The bi-turbo version seeks to improve response and power through a system of two turbochargers that operate sequentially, a small one for low-rev response and a larger one to sustain thrust at high engine speeds. Under ideal conditions, this approach allows a combination of strong initial acceleration with greater sustained power. The practical implementation of this system requires complex electronic management. Valves, actuators, and sensors control the distribution of exhaust gases between both turbos and adjust the variable geometry of the vanes. These components operate in an environment of high temperatures and exposure to combustion residues. With use, especially in dusty environments or with irregular maintenance of the intake system, the variable geometry mechanisms can accumulate carbon deposits that restrict their movement. The first symptoms are usually a gradual loss of response, drops in power at certain engine speed ranges, or the system entering protection mode. When one of the turbos loses efficiency, the balance of the system is altered, generating less favorable thermal and mixture conditions for the engine. This can accelerate wear on other components. Maintenance and repair costs of a bi-turbo system are significantly higher than those of a single turbo. Each turbocharger and its actuator represent costly components, and labor for replacement is high due to limited access in the engine bay. In addition, not all workshops have the necessary experience to diagnose these systems, which often results in greater dependence on dealerships or specialized services. The D-Max bi-turbo offers improved performance figures but introduces complexity that can affect long-term durability and operating costs. For users who prioritize mechanical simplicity and predictable maintenance, single-turbo versions usually represent a more conservative option and, in many cases, more suitable for prolonged use. 5. Ford F-150 Power Boost, the brilliant hybrid with a thermal Achilles heel. The F-150 Power Boost integrates a twin-turbo V6 engine with an electric motor in the automatic transmission, forming a hybrid system aimed at improving efficiency without losing work capability. Added to this is the Pro Power onboard system, which turns the pickup into a mobile generator capable of powering tools or equipment on job sites. Under normal use, fuel consumption is lower than in conventional versions of similar power, representing real operational savings. The main challenge of this setup is thermal management. The twin-turbo combustion engine, electric motor and power inverter generate heat simultaneously within a confined space. To control it, the vehicle uses several cooling and oil cooling circuits with interconnected pumps, sensors, valves, and heat exchangers. This complexity increases the number of potential failure points. Under demanding conditions such as prolonged towing, intensive generator use, or hot climates, the system can operate near its thermal limits. If localized overheating occurs, the coolant loses efficiency and, in adverse cases, the seals of the heat exchangers may degrade. This opens the possibility of cross-contamination between coolant and oil, compromising internal engine lubrication and accelerating wear of bearings and critical components. If not detected in time, the damage can lead to major repairs. Diagnosing failures in the hybrid system is often complex, as symptoms may be intermittent and causes not always evident. A problem in sensors, inverter, battery, or electric motor can generate secondary effects in other components, increasing the total repair cost. During the warranty period, these risks are covered by the manufacturer. However, out of warranty, the combination of technical complexity and component costs makes the Power Boost an option with greater long-term financial exposure. In the used market, this perception is already reflected in more pronounced depreciation compared to versions with conventional powertrains. 4. Mitsubishi L200, aged platform facing modern demands. The Mitsubishi L200, also known as the Triton in some markets, has built its reputation on mechanical robustness, affordable acquisition costs, and relatively accessible maintenance. This continuity has facilitated the availability of spare parts and technical knowledge among workshops, which remains an advantage for those seeking predictability in maintenance. The challenge arises because the current architecture is an evolution of platforms over a decade old. Although it has received updates in design and equipment, it retains structural foundations that were intended for lower load and towing demands than are common today. Current expectations include higher payload capacities, heavier towing, and the addition of accessories that increase the vehicle's total weight, such as roof tents, toolboxes, and larger tires. Under frequent use near its limits, the ladder chassis may operate closer to its structural margin. In high-mileage, intensive-use units, specialized workshops have reported fatigue cracks in stress concentration areas, such as suspension mounting points or chassis section changes. These cracks, though initially microscopic, can propagate over time and compromise alignment and structural integrity if not addressed promptly. Repairs of this type are complex and costly. Another sensitive point is the rear differential when the vehicle is used in dusty environments or with consistently heavy loads. The entry of abrasive particles can accelerate wear on gears and bearings, generating noise, vibrations, and, in advanced cases, complete failure. Rebuilding a differential requires specialized labor and significant expense. Compared to more recent rivals, the L200 shows disadvantages in structural rigidity and safety margins for prolonged intensive use. Modern platforms incorporate high-strength steels and optimized designs to better withstand sustained heavy loads. The L200 remains a valid option for moderate use and shorter renewal cycles, where mechanical simplicity and low spare part costs are priorities. 3. Hyundai Santa Cruz, the crossover pickup experiment. It proposes a reinterpretation of the pickup concept by combining SUV elements with an open cargo bed. Unlike traditional pickups with a ladder frame and solid rear axle, it uses a unibody platform derived from a crossover. This approach provides better comfort, more stable road handling, and higher efficiency, but introduces structural limitations for constant load use. The independent rear suspension, with control arms and rubber bushings, is sized for typical SUV loads. When the vehicle is repeatedly used near its maximum payload capacity, the bushings begin to deform permanently. This deformation alters suspension geometry, causing uneven tire wear, loss of driving precision, and a progressive feeling of instability, especially under load. The rear shocks are calibrated for urban comfort. Under high load and frequent use, they operate outside their optimal range, overheat, and lose damping capacity more quickly. In these scenarios, they often require replacement at shorter intervals than a conventional SUV, increasing maintenance costs. The degradation of bushings and shocks increases the transmission of vibrations to the cabin, generating noises, creaks, and a perception of reduced solidity over time. This can lead to discomfort for occupants and progressive loosening of interior components. The main challenge of the Santa Cruz is the gap between its commercial image and its sustainable long-term capabilities. For occasional light load use or transporting bulky items, the vehicle can be practical and efficient. However, for those seeking a pickup for frequent work, daily load, or continuous towing, its architecture is not designed for that level of demand. 2. Rivian R1T, the electric revolution with a repairability Achilles heel. The Rivian R1T is one of the most ambitious attempts to redefine the pickup for the electric era. Its design starts from scratch without inheriting combustion vehicle platforms. It uses 4 independent electric motors, one per wheel, allowing highly precise traction management. The structural battery lowers the center of gravity and adds rigidity, while the central cargo tunnel and adjustable air suspension provide practical solutions for daily and off-road use. Under ideal conditions, range exceeds 500 kilometers, and the interior offers a high level of comfort and technology. The problem is not its performance, but its repairability after collisions. Rivian adopts the mega casting technique, which involves casting large sections of the chassis in a single aluminum piece. This simplifies production and improves rigidity, but eliminates the possibility of localized repairs. In a conventional pickup, damage in one section of the chassis can be fixed by replacing only the affected part. In the R1T, any damage to a cast section requires replacing the entire piece. These monolithic parts are costly and logistically challenging. Their replacement requires specialized equipment and long lead times. When the damage is combined with components of the battery system or the front or rear structure, total repair costs can quickly approach the value of the vehicle. For this reason, insurers tend to declare a total loss in accidents that would be repairable in other pickups. This scenario has impacted insurance premiums and the used market, where the R1T shows faster depreciation than the segment average. Although the manufacturer is working on partial repair processes for these structures, they are not yet widely available solutions. 1. Tesla Cybertruck, the polarizing future with a problematic present. The Tesla is one of the most polarizing vehicles of recent years. Its stainless steel design breaks segment conventions and generates extreme reactions. Beyond aesthetics, it represents a radical approach to pickup design, with technical solutions uncommon in the industry. One of the most debated points is the drive-by-wire steering system, which eliminates the direct mechanical connection between the steering wheel and the wheels. This approach allows variable steering ratios and greater design flexibility, but also concentrates operation in sensors, software, and electric actuators. Although the system incorporates electronic redundancies, the absence of a mechanical backup raises concerns in complex failure scenarios. The exterior stainless steel structure offers high surface resistance, but its rigidity limits the ability to absorb energy through controlled deformation in impacts. In collisions, a very rigid structure can transfer greater forces to occupants and other road users. Additionally, stainless steel can develop surface corrosion in environments with salinity or intensive use of de-icing salts, requiring more frequent maintenance than expected to preserve appearance. Repairability outside the manufacturer's service network is limited. High-strength steel panels and proprietary systems complicate interventions in independent workshops, which can result in long wait times and high costs. This situation, along with the adoption of technologies still maturing, is reflected in a more cautious used market with accelerated depreciation. The Cybertruck offers a radically innovative proposition for those prioritizing technological novelty. However, for users seeking a pickup as a work tool with predictable costs and accessible repairs, its experimental approach represents a high risk. At the end of the day, the current market delivers a clear lesson. A pickup that is not designed to last is not a work tool, but a financial liability on wheels. Today, we reviewed 13 pickups that promise power, technology, and status, but out of warranty become a constant expense with repairs that can reach very high figures in a short time. The question is direct. Will you choose marketing wrapped in steel or engineering that respects your money and your time? If you have already had problems with any of these pickups, or if a mechanic helped you avoid a costly mistake, share your experience in the comments. Subscribe to make decisions based on real data, not advertising promises.